holding a tablet that was written thousands of years ago and being able to read what it says. It's an amazing feeling. For over a century, it was just another broken clay tablet collecting dust in a university archive. You see a formed tablet for the first time. You're not likely to identify it as writing. But when AI finally decoded it, everything changed. This 3,700-year-old Babylonian artifact didn't just rewrite history. It sent a chill down the spine of every expert who saw the results. What it revealed wasn't a myth, a story, or a prayer. It was something far more advanced and far more terrifying. Welcome to the story of Plimpton 322, the ancient Babylonian tablet decoded by AI. What it showed is terrifying, and it might be the biggest historical revelation you were never supposed to see. Buried under dust, forgotten by time. In the scorching sands of southern Iraq, among the ruins of long-lost cities and crumbling ziggurats, a small cracked clay tablet was pulled from the earth in the early 1900s. At the time, it didn't look like much. Roughly the size of a pocketbook covered in unfamiliar markings and missing some of its corners, the artifact seemed like just another piece of Babylon's forgotten past. The man who found it, Edgar Banks, was an archaeologist, an antiquities dealer, and funnily enough, the real-life inspiration behind the fictional character, Indiana Jones. He had no idea what he had just uncovered, and neither did the world. The tablet was eventually sold and made its way to Columbia University, where it sat quietly for decades under the name Plimpton 322, part of a larger collection donated by George Arthur Plimpton. Even then, very few people gave it a second look. It was ancient, yes, and inscribed in puny form, the wedge-shaped script used by the Babylonians. But its meaning was opaque. It wasn't until the 1940s that a few historians began to suspect that this tablet wasn't recording a king's conquests or a list of trade goods. It was doing something far more curious. It was calculating. Researchers noticed a strange sequence in the numbers etched into the 4 columns in 15 rows. They didn't look random. In fact, they resembled the kind of numbers that appear when solving right triangles. Specifically, they seem to follow a pattern now known as the Pythagorean theorem. The square of the hypotenuse equals the sum of the squares of the other two sides. That discovery alone was shocking. The Babylonians lived around 1800 BC. Pythagoras didn't come along until more than 1,000 years later. So, how did they know this? At first, many dismissed the resemblance as coincidence. After all, the Babylonians were known for basic arithmetic and keeping records of trade. But the more researchers looked at Plimpton 322, the harder it became to ignore. The numbers were too specific, too consistent. Still, for nearly a century, the tablet remained a mystery. People couldn't agree on what it was for. Was it a list of exercises for scribal students, a reference sheet for builders, or something else entirely? The answer remained elusive, mostly because of what the tablet was missing. Parts of it were chipped away. Whole rows were gone. Without the full data, any theory was open to challenge. And so, Plimpton 322 drifted into obscurity again. Known to math historians, but largely ignored by the world at large. That would change, however, when a new kind of mind began to study it. Not a human one, but an artificial one. The rebirth of interest in Plimpton 322 came not from a dusty archive or a chance discovery in a museum drawer, but from an Australian mathematics professor who saw a photo of it while designing a curriculum for high school teachers. His name was Daniel Mansfield. And like Banks before him, he couldn't shake the feeling that the tablet was important. But this time, there was a new tool available. One that could help decode patterns in ways the human brain simply couldn't. AI. With modern machine learning models capable of scanning, reconstructing, and interpreting ancient scripts and numerical data, the cracked tablet suddenly became a live wire. Algorithms began filling in missing sections, spotting connections, and proposing translations. And what they found inside the damaged clay was enough to make experts rethink not only the purpose of this tablet, but also the timeline of human mathematical history. What looked like a fragile relic was actually something much more sophisticated, something that might not have belonged in its time. Something that could change how we understand the evolution of human knowledge. But the truly disturbing part wasn't just what it showed. It was how accurate it was. The numbers no one could explain. For decades, the numbers on Plimpton 322 sat in academic limbo. Scholars knew they meant something, but what exactly that was remained frustratingly unclear. The tablet contains 15 rows of numbers written in base 60, also known as sexagesimal, the numerical system the Babylonians used. Each row includes 4 columns of figures with some sections missing due to erosion. At first glance, it looked like a dull accounting record. Maybe something related to grain storage or temple inventory. But the structure was too deliberate, too orderly, too mathematical. In the 1940s, researchers made a breakthrough that would set the stage for every theory to come. They noticed that the numbers weren't random. In fact, many of them corresponded to what we now call Pythagorean triples, sets of 3 whole numbers that satisfy the Pythagorean theorem. Plimpton 322 didn't just include one of these sets. It had multiple, and they were arranged in a meaningful way. This immediately sparked controversy. If the Babylonians had knowledge of Pythagorean triples, that would mean they understood the concept of right-angled triangles over 1,000 years before the Greeks formalized it. And they weren't just guessing. These triples were mathematically sound. Some scholars believed it could have been used as a kind of teacher's guide for training scribes in mathematical exercises. Others thought it might have been a reference tool for architects or builders. Still, no one could definitively explain why these specific number sets were chosen or what their intended use actually was. Adding to the confusion was the tablet's missing corner. Because it was broken, there were gaps in the data, missing rows, partial columns, and crucial context lost to time. Without those pieces, every explanation came with a maybe or possibly. Some historians argued that the Babylonians stumbled upon these triples through brute force calculations without understanding the underlying geometry. Others insisted that the patterns on Plimpton 322 showed a deep and deliberate knowledge of mathematical relationships. And then came the format. The Babylonians weren't writing in angles or degrees. That's a Greek invention. Instead, they used ratios of side lengths. This detail would become critical much later, but for years, it left researchers scratching their heads. Why would anyone make a table of triangles without referencing angles? It was like seeing the answer to a puzzle but not knowing the rules. While the academic world debated and theorized, Plimpton 322 remained stuck between two worlds, part artifact, part riddle. It was clearly mathematical, but it didn't fit comfortably within modern frameworks. It was too advanced for its time, yet missing the vocabulary we expected to see, and so it drifted in scholarly journals and textbooks, referenced occasionally, but never truly understood. Meanwhile, the idea that an ancient civilization could possess such precise mathematical thinking without modern notation or tools started to gain traction in fringe circles. Conspiracy theorists and pseudoscience fans began to float wild ideas. Was it alien technology? Evidence of a lost advanced civilization? Most historians and mathematicians dismissed these claims outright, but the core mystery remained. How did a society from 1800 BC, one without calculators, without trigonometric functions and without any known geometric texts, manage to construct something so specific, so structured, and so difficult to explain? What made it more unsettling was the silence around it. There was no companion text, no surviving instruction manual, no detailed commentary from the Babylonians themselves explaining what they had done or why. Plimpton 322 was left to speak for itself. A lone voice from an ancient world whispering numbers no one could fully understand. At least not yet when AI got involved. For nearly a century, Plimpton 322 sat in the gray area between fascinating and frustrating. Historians knew it was unusual. Mathematicians knew it was precise. But without a complete tablet, a consistent interpretation or a clear context, the mystery remained locked in the clay. That changed when modern tools, specifically artificial intelligence, entered the picture. It started when mathematician Daniel Mansfield, while developing a high school curriculum in Australia, stumbled across an image of the tablet. Something about it caught his attention. The pattern, the structure, the ratios, it all hinted at something deeper. Mansfield wasn't the first to suspect trigonometric significance, but he was determined to figure out exactly how. So, he teamed up with his colleague Norman Wildberger at the University of New South Wales. And together, they decided to let AI do what human intuition couldn't. By using pattern recognition software trained on Babylonian ununiform and mathematical sequences, Mansfield and Wildberger were able to reconstruct the missing pieces of Plimpton 322 with surprising accuracy. The AI combed through other tablets from the same era, learning how numbers were expressed, how certain patterns repeated, and how the Babylonians documented their data. This allowed the software to propose credible reconstructions of the missing values and reframe the entire table as a complete dataset. That's when the bigger picture snapped into focus. According to the reconstruction, each row on Plimpton 322 described a right triangle using exact ratios between its sides. But here's the key. The Babylonians weren't calculating angles the way the Greeks later would. They weren't using degrees, radians, or trigonometric functions like sine and cosine. Instead, they were working with pure side ratios, the length of one side compared to another using their base 60 number system. This method, according to the researchers, was not only functional, but potentially more precise than modern trigonometry, which relies on decimal approximations. The Babylonians, it seemed, had discovered a system of trigonometry that was entirely different from the one taught in classrooms today. And they had done it 1,000 years before the Greeks formalized theirs. The AI's analysis didn't just fill in the blanks. It revealed something astonishing. Plimpton 322 was no random collection of numbers. It was a coherent, structured, and efficient table of trigonometric relationships. And more importantly, it was practical. This wasn't abstract theory written for intellectual show. It could have been used by surveyors, engineers, or architects. If this interpretation held, it would mean that ancient Babylonians not only understood complex geometry, but also developed a unique and powerful method to apply it. The implications were massive. For decades, the Greeks were credited with inventing trigonometry. That narrative now had to shift. AI had uncovered something that challenged the foundational timeline of mathematics itself. It wasn't just that Babylonian math was advanced. It was that it may have come first and in a form that was arguably more elegant in certain applications. Naturally, the theory wasn't without its critics. Some scholars pushed back, warning that the AI's reconstruction was speculative, filling in broken tablets with machine-suggested values. No matter how sophisticated, the model wasn't foolproof. But even they couldn't deny the internal logic and mathematical consistency of the results. It fit too well to ignore. And if the Babylonians really did invent their own system of trigonometry, one based on exact ratios and completely independent of angles, then we're not just talking about an ancient math tool. We're talking about a civilization whose understanding of geometry might have rivaled or even surpassed what we've assumed for millennia. AI didn't just solve a puzzle. It revealed a version of history that's both brilliant and deeply unsettling. Because it raises a much larger, more haunting question. If they could do this, what else did they know? What the tablet actually shows is terrifying. It started with a broken slab of clay and now it was rewriting history. After AI-assisted analysis filled in the missing gaps, researchers were no longer just interpreting Plimpton 322 as a mathematical curiosity. What they were seeing bordered on something else entirely. For a civilization from 3,700 years ago to construct a table this accurate, this advanced, and this intentional, it shook the foundation of what we thought we knew about ancient knowledge. The numbers on Plimpton 322, once thought to be mere lists or scribal drills, now lined up perfectly as part of an exact functioning trigonometric table. Not based on angles, not based on sine or cosine, but on pure clean ratios of triangle sides expressed in Babylonian base 60. The kind of system that doesn't rely on approximations or rounding errors the way our modern trigonometric functions do. According to reports, these calculations were so precise that even today's high school math textbooks don't deliver this kind of accuracy without a calculator. And that's when it hit. This wasn't just a coincidence. This was design. Whoever made Plimpton 322 knew exactly what they were doing. The rows weren't arbitrary. They were sequenced with intention. The ratios were ordered from steep to shallow, suggesting the tablet may have been used like a reference guide, perhaps by engineers, architects, or surveyors. And the more researchers dug into the reconstruction, the more it felt like the tablet wasn't a product of basic arithmetic. It was a full-on mathematical tool. The phrase that started appearing again and again in interviews and reports, "This is absolutely insane," because it is. A 3,700-year-old Babylonian tablet decoded by AI turned out to be more than just a historical artifact. It showed a mathematical system far ahead of its time. And the fact that it had sat on a shelf at Columbia University for over a century only made the discovery more unsettling. Imagine this: while most of the world in 1800 BC was still navigating early metallurgy and tribal governance, someone in southern Mesopotamia created a portable tool capable of describing right triangles with pinpoint accuracy. A civilization long buried beneath layers of war, erosion, and history had for a moment peeked into a mathematical future we thought belonged to the Greeks. It didn't. So when headlines began to appear, 3,700-year ancient Babylonian tablet decoded by AI, what it showed is terrifying. They weren't exaggerating. It wasn't terrifying because it was dangerous. It was terrifying because of what it revealed about us, about our assumptions, about how much we've overlooked or simply refused to see. And it wasn't just Plimpton 322 standing alone. As discussed by Mansfield and others, when paired with another tablet, Psi 427, a Babylonian field plan used for surveying, it began to paint a larger picture, a civilization not only capable of abstract math, but also applying it to real-world problems with a level of precision that should not have been possible at the time. That's what AI didn't expect to find. It wasn't looking for lost knowledge. It was trying to solve a math puzzle. But what it found was a system, intentional and repeatable, embedded in a crumbling piece of clay. We often talk about ancient wonders in terms of architecture, pyramids, ziggurats, stone circles, but this was different. This was invisible, quiet, locked in symbols and numbers. It took us nearly 4 millennia and the help of artificial intelligence to begin to understand it. And even now, we're left with questions that have no easy answers. Did the Babylonians develop this system entirely on their own? Was it passed down from an even older culture? How many other tablets like this are still sitting in museum basements waiting for someone or something to look at them the right way? What Plimpton 322 shows isn't just terrifying because of what it contains. It's terrifying because it reminds us how much we may have already lost. The shadow of Psi 427. While Plimpton 322 stunned the world with its theoretical brilliance, another Babylonian tablet quietly reinforced the idea that this wasn't just math for math's sake. It was applied. And that might be the most chilling part. The tablet known as C427, roughly the same age, about 3,700 years old, wasn't discovered in a temple or a library. It was found in the context of a legal dispute over land. Unlike Plimpton's numerical maze, C427 contains a diagram, a literal map of a field etched into clay with annotated measurements and notes. It's the kind of thing a modern surveyor might sketch out when laying property boundaries. Only this one was created centuries before the concept of geometry even existed in name. At first glance, C427 seems mundane. A field map. What could possibly be exciting about that? But the closer researchers looked, the more it became clear. This wasn't a rough sketch. It was a geometric plan complete with right angles, proportional measurements, and a clear understanding of spatial relationships. Whoever made it was using mathematics to solve disputes, to define ownership, and to settle matters of law. That alone places Babylonian math not in the realm of philosophy or abstract theory, but in the very real and practical domain of power and governance. And here's the eerie part. The person who made C427 would have had to rely on something, some reference system, some way to understand how lengths and angles relate. Plimpton 322 fits that role. It could have served as the surveyor's tool, one tablet to lay out theory, the other to execute it in the real world. That connection didn't go unnoticed. Daniel Mansfield, one of the researchers behind the AI decoding of Plimpton 322, believes C427 is a critical piece of evidence that ties the entire puzzle together. If Plimpton 322 is the calculator, C427 is the blueprint. According to Mansfield, what makes C427 so important is that it shows intentional use of geometry in property law. That's not just impressive, it's deeply unsettling when you think about what it implies. A society using advanced math to define legal ownership, enforce